Aw, forget it. A spark is a small fiery particle thrown from a fire. It can also be produced by striking two hard surfaces together, such as stone or metal. But it can also be defined in the sudden flow of electrical current across an air gap. Check out the sparks found right here in the theater. In metalwork, grinding is the act of sharpening steel on a grinding surface. The metal particles are so hot from the impact that they oxidize. Upon contact with oxygen in the air, the tiny iron particles spontaneously ignite. More on these incandescent particles, one should study solid-state physics. Just ask Dr. Patricia Sparks of Harvey Mudd College, whose study includes the optical properties of metals and interfaces. Welding involves heating two pieces of metal so that they melt and fuse together, resulting in a very strong seam. This requires scorching temperatures of around 5,500 degrees Celsius, which are most commonly generated with an electric arc. As the arc is drawn along the join, both the tip of the electrode and the working materials become liquid and fuse together. At such high temperatures, the molten metal bubbles and spits, expelling a shower of incandescent droplets. These are the sparks you see. They can be as hot as 1,300 degrees Celsius, so be sure to stand clear and have your safety preparations in place. The light emitted from the welding arc is at wavelengths which are damaging to human eyes. Special safety shields can be put up to protect workers around you while you are welding. A theater arts scene shop is the perfect place to practice your welding skills. Not everything needs to be structural, and you get to work on some amazing designs. Awareness of the most common welding hazards and knowing how to avoid them ensures a safe, productive work environment for all. Safety is a critical consideration for any welding project. Arc welding is a safe occupation when proper precautions are taken, but if safety measures are ignored, welders face an array of hazards which can be potentially dangerous, including electrical shock, fumes and gases, fire and explosions. An arc is a discharge of electrical current, just like a tiny lightning bolt. In arc welding, the parts to be welded are connected to a grounded wire, and an electrode is connected to the power supply. When the electrode is put into contact with the welding materials, then moved away, the air in between the two is ionized, and electrons leap across the gap. This generates bright light and intense heat. An electro-pounce machine reduces time and workload for artisans, saves time and money by simply drawing with this electric pencil rather than using an outdated pounce wheel. Crisp, clean holes of various sizes can be easily pounced in one or many sheets of paper by simply adjusting the voltage dial. The electric spark created is an abrupt electrical discharge that occurs when a sufficiently high electric field creates an ionized electrical conductive channel.
No, I'm not good.
Here are two BU students learning the art of the electro-pounce and using it on scenery for an upcoming show.
Tell me right in. You can cover something in masking tape and that's good enough. So you always check that the button on your pants is covered. This flannel I know only has plastic buttons, so I'm otherwise covered. I'm going to take my watch off like an adult. I'm going to put it here and I'm not going to get it. Oh, I pocket. You can wear metal on your body. You just can't touch metal and keep it. Yep. So, To get through craft paper, you probably need about 40 minutes. Get through bogus paper like
Although
40
it is not as dangerous as metalwork, precautions still must be taken to keep the artisan and those around them safe.
The other thing you have to keep track of is you can't see what you're doing. Great. So make sure you do it, since you have squares on here, go square by square. Don't follow the line. You will get lost if you're doing something more complicated. So just like do the bit that comes in. If straight lines really mattered, you would do this with a ruler. If you did this with a yardstick, you would cover the metal part of it with masking tape. We're not doing that. So then I've completed the square and I know I've done it and you can't get lost. And you go up to the next one. So generally don't get your fingers within like 2 inches of it because a spark could jump. But like that is not as strong of a shock as if you jab it into your chest. And I survived that, so you can survive this. Yep. So yep. Yeah, just put your hands on it. You'll be fine. Okay, we're fine. Yep. The very last thing to think about is everybody that walks by is going to come and say hi to you and lean on the table. No! And you tell them, no, the table is live, don't touch it. As long as your pointer isn't down, you haven't completed the circuit. Right. So even though it's attached at one end, like, it's fine. But spectators.
The small sparks created are due to the potential difference from the electrode to the surface of the table. When the space between the two becomes small, the pencil getting close to the table, electrons are attracted to this opposite side of this potential gap, and they jump across, emitting the small spark. Once you get over the basic safety protocols, Electro-Pouncing can be a very rewarding and relaxing project. Just watching here makes me feel calm and excited. And then knowing that you've got these little sparks happening under your hand gives you just that much amount of thrill. And if you're like me, you're wondering, what's making that spark? Where did it come from? And why is it helping me do what I need to do? On the subatomic level, Electro-Pouncing could often be confused with atom excitation. Electron transitions, such as excitations and de-excitations, are changes in the energy level of those particles. This transition results in the release of a light particle. Electrons and protons can be excited in the nucleus, and when they come down, they release a particle called gamma radiation. This quantum particle is known as a photon. Unlike any wavelength you can identify, a gamma ray can pass through many types of materials. A photon is not a spark, but it does have very similar qualities. This has been another episode of Physics for Show. And if you enjoyed this video and want to see others like it, like Physics for Show on Facebook and find me on LinkedIn. I'm Rita Roy, and this has been another episode of Physics for Show about the wonderful phenomenon of sparks.